And let's think about 25. 25 can be written as 5 times 5, where 5 is prime number as well. So that's all we got for this question. So 100 can be written as 5 times 5 times 2 times 2. And so we'll stop here since all the factors are now prime numbers. And I'll just write it down. So prime factorization of 100 is 5 times 5 times 2 times 2. Yep, so that's the answer for the question. And also, there's another way of solving this, which I personally prefer. So whenever we have a number want to be factored, I was writing this form. So 100 can always be written as 20 times 5. And also 20 can be written as 4 times 5. And the 4 can be written as 2 times 2. Right. And so the prime factorization of it will just be the number at the end of each branch. So it'll be 2 times 2 times 5 times 5, which is exactly the same as what we did previously. Yep. So this is correct as well. Right. So for our next question, we need to find out the area of a quarter circle. Area of a quarter circle. Okay. Right. So a quarter circle is defined as 1/4. Divide one circle into 4 pieces, and we just take one of them. And so the area of a quarter circle is 1/4 of the area of a whole circle. I'll draw a diagram just for better illustrating. So we divide this into 4 pieces. So number 1, number 2, number 3, and number 4. And we just need to take any one of them. Will be a quarter circle. And note that the area of quarter 1 is equal to the area of quarter 2, equal to area of quarter 3, equal to the area of quarter 4. Yeah, so these are all equal. And since we know the area of one complete circle is A is equal to pi r squared, and where r is the radius of a circle, so we just need to simply divide it by 4. So the area of a quarter circle is pi r squared over 4. Yeah, which can be also written as 1/4 times pi r squared. Right. So let's do a example help us better understanding how we can apply this to the actual problems. So if we have, let's say, a radius of 6, and they ask us to find the quarter area of the quarter circle. So now we know by applying the formula we have above, we know area is equal to 1/4 times pi r squared, which will be 1/4 times, since at this in this case r is equal to 6, so it'll be 6 squared, which is 1/4 times pi times 36. and we put a constant together will be 36 over 4 times pi, which will be 9 pi. That's our final answer. Or in the diagram, there will be 9 pi, 9 pi, 9 pi, 9 pi for each quarter circle, but the area of this whole circle will be 4. And let's leave a comment there. Good work. Correct. So our next questions, they ask us to find the disk method formula. So disk method formula. I just need to charge my computer. Okay. Right. So first, let's write down what it is. So in calculus, disk method is a way of finding of a solid generator. When the graph of a function is revolved, and then the solid is divided into many small cylinders, or we say disks, and the volume of which are added together. So I'll just draw a diagram for better understanding. Yeah, so as you can see in the yellow area, there looks like a bunch of disks packed together, and yeah, that's what we call a disk method. And the formula of it will be already down here. So the volume is equal to pi to the integral of AB fx squared dx. And so for A, it is just the lower limit. B will be the upper limit. And the dx, it just slides along y. So yeah, and also we can see from the description on the left side of the square of the function fx from point A to point B, which is represented by the lower point and upper point, and multiply by pi, which is also 3.14. And I think we can also just leave as pi. And the radius of the cylinder is given by the function fx, where the height is dx, and mathematically, as delta x is approached to 0, and the number of disks goes towards infinity, then we'll have the actual volume of the project rather than a mere estimate. Right. So by knowing that, as we mentioned about, normally we just rotate it around x-axis and y-axis, and so now I'm going to share the horizontal axis of revolution and the vertical axis of revolution. So the volume for horizontal axis of revolution BV is equal to pi AB Rx squared dx, and the volume for vertical axis of revolution will be V is equal to pi let's do P and Q. Ry dy. So I prepare an example for us to help better understanding how to apply this to our actual problem. So let's take y is equal to x squared between x equal to 0.6, x equal to 1.6, and rotate it around the x-axis, and we're looking for the volume of it. Question like this, the first thing I suggest is draw a diagram. Plus better understanding what the question better illustrating for us to solving the problem. So let's draw a graph of this. So that's 0.6 and 1.6. 0.6, let's just do here, 1.6. And that's y. And we want to rotate it around axis. So let's use another color. So after rotating the x-axis, it will become a graph like this. So the yellow area will be the volume. So after knowing what the graph looks like, we'll apply our formula and solve the integration. So volume is equal to integral. Remember, the bottom part should be the lower limit, which in this case will be 0.6, and the upper part will be our upper limit, which is 1.6. Oops. Only this part. because it should be between 0.6 and 1.6, so we don't need to worry about the part on the left side of 0.6 or the part on the right hand on the right of 1.6. So supply formula, we have pi x squared dx. So we can always move the pi to the outside first. So we have pi 1.6 0.6 x squared dx. And we also know x squared is actually x to the exponent of 4. So we will write the question to 0.6 1.6 x to the exponent of 4 dx. And the integral of x4 is 1 over 5 x to the exponent of 5 plus c, and between 0.6 and 1.6. So we got pi times So we'll get roughly 6.6 as our answer. Yeah, so just do a little summary here. There's some things to mention about. The first thing will be the limit part, will be the lower bound and upper bound. Like you don't need to solve all of them, but just a part that inside the interval. And always move the pi out from the integral first, and then yeah, so quadratic formula. So first, let's write down the quadratic formula, which is x is equal to negative b, positive negative b squared minus 4ac over 2a. And this formula is using finding the root of equation in this form. So whenever you see a question in ax squared plus bx plus c is equal to 0. Yeah. So the root of this equation can be determined by substituting the values of a, b, c in the quadratic formula. So let's do example. I'll just use the example the junior tutor has. So x squared minus x minus 6 is equal to 0. Yep. To the pink color one about, so we know a in this case equal to 1, b is equal to negative 1, and c is equal to negative 6. Always remember to take the sign in front of the number. Don't just take c is equal to 6, right? So after knowing this, we're going to substitute these values in the quadratic formula, which is, let's copy down the formula first, negative b squared minus 4ac over 2a, which is equal to this negative 1. I will just leave in this form for now. So b squared minus 4 times 1 times negative 6. And the bottom part is just 2 times 1. Right. And we will solve this. We got, because negative 1 becomes to 1. And in the square root, we got 24, we got 25, right, 1 minus Yeah, 1 plus 24, we got 25. And for the denominator part, just 2 times 1. So we have 1 u25 over 2 as our answer. And remember, u25 is equal to 5. So we can rewrite the question. Rewrite our answer as 1, 5. So x1 will be 1 plus 5 over 2, and x2 will be 1 minus 5 over 2. So the first thing will be 3, x will be negative 2. Yeah. So the two roots we got here is 3 and negative 2. Yeah. So by knowing this, I want to do a little bit summary, and I'll just develop a little bit more. So summary. So we have x is equal to 2a negative b plus minus 4ac. So x1 will be 2a negative b plus root square of b squared minus 4ac. And x2 is equal to 2a negative minus root b squared subtract 4ac. Right. And another thing is, other than just normally solving the problems, there are also how we're going to solve this question. Are we just going to do a is equal to 1, b is equal to negative 2, c is going to be negative 4? Because, yeah, they're still corresponding. So in this case, we cannot do this. Since recalling what we have previously, we can only apply quadratic formula when the right-hand side is equal to 0. So whenever we got a constant on the right-hand side, we always need to move to the left-hand side and combine with the existed constant in order to get a 0 on the right-hand side. So we just need to simply do one more step. So we just need to move the 4 to the left. So we got x squared minus 2x minus 4 is equal to 0. And then we have x squared minus 2x minus 8 is equal to 0. Yeah. So since now we have the form of ax squared plus bx plus c equal to 0. See, we have a 0 on the right hand side. Now we can apply the quadratic formula by applying the ABC. Right. Come in there. Good work. Is correct. So let's do our final question for today's surface hour. So for this question, we need to add a whole number and a proper fraction. Right. So let's first clarify what is number and proper fraction. So the whole number, I'll just write it down. Whole numbers like 1, 2, 3, and also 0, 4, 5, 6, And a proper fraction is a fraction that is less than 1 and the numerator is less than denominator, which means the top has to be smaller than the bottom. So proper fraction could be like 1 over 2, 2 over 3, 3 over 4, and it's like 10 over 1,000. So when we're dealing with adding a whole number to a proper fraction, we just simply combine the whole number and the proper fraction, and the combined fraction is what we call a mixed number. And in case a mixed number is converted to improper fraction, multiply the denominator by the whole number plus the numerator, and the result will be the number, and the denominator is copied as denominator. So let's do example. The proper fraction will be 2 over 3, and the whole number will be 5. So the first we can combine them together, which will be 5 plus 2 over 3 will be 5 and 2 over 3. And if we want to convert the mixed number to an improper fraction, we need to multiply 3 and 5, and the result will be added to 2. And notice that 3 is a copy as a denominator, so we got 5 times 3 plus 2, which will give us a 17 as our new numerator. So the final answer will be 17 over 3. And also there's another way of doing it. So we have still the same whole number and proper fraction. We have 5 plus 2 over 3, and we want to maintain 3 as the denominator. So we want to convert 5 to a fraction that has a denominator of 3. So we want to convert 5 to a fraction, like as a whole is a fraction, with a denominator of 3. So 5 times, we times 3 on the both sides, and we have k is equal to 15. So we know 5 can also be written as 15 over 3. Yeah. So now the question actually converts to 15 over 3 plus 2 over 3. Since they share the same denominator, we can just do the adding on the numerator, which will be 15 plus 2, and so we maintain the numerator. Maintain the denominator, which gives us 17 over 3 as our final answer. So 17 over 3, 17 over 3, either way works. Right. And I think that's a wrap for today, and those are all the questions for today. If you enjoyed today's Q&A and would like to be notified of when we do this next, please hit the subscribe button and notification bell below. If you would like to submit your own questions, visit the links in the description. Remember to leave a like or comment and share this video with a friend. As this has been Andrew from OneClass. Hope to see you soon. Bye.